Good morning, students. Today I'm going to discuss with you two very important algorithms, BFS and DFS. These are your graph traversals algorithms. Like in tree, we have already done that there are three types of traversals: pre-order, in-order, and post-order. Similarly, in graph, if you want to traverse a graph, traversing a graph means visiting each and every node of that graph. So we have for that, we have BFS. This is called breadth first search, and this is called your depth first search algorithms. Okay. So first of all, I will take BFS. Suppose I have taken, this is your breadth first search. I have taken this graph. Okay. Now first I will tell you that what's the meaning of this here breadth and depth. Okay. Now suppose I want to traverse, I want to visit all these nodes breadth-wise. Now breadth-wise means you can say level-wise. Firstly, suppose if you are starting from 1, you can start from any node. If you are starting from 1, then first of all, we will visit all the nodes that are connected to 1. So what are the nodes connected to 1, 2 and 3? That means firstly you will go to that node. You will traverse 1 first. Then you will go to all the nodes connected to 1. So I will go to 2 and 3. So they will be visited. They can be visited in any order. You can write down 2, 3 or 3, 2. So first suppose I have taken here 2 and then 3. After that, next level nodes you will traverse. Suppose if I am taking 2, all the nodes connected to 2. That means 4th and 5th one. And then you will go to this 6th one. That means breadth wise, like this, level wise, you are traversing these nodes. But in the depth first search, the order would be different. Okay, so if you are starting from 1, after 1, suppose you are visiting this second node. After visiting this second node, you don't have to go to this 3. First, you will go to all the nodes connected to 2. That means, suppose I am visiting then 4, then all the nodes connected to 4. It can be 6, it can be 5. Suppose if it is 6, after 6, you are backtracking and going above, and you are visiting then 5 and then 3. Okay. So that means if you are using depth first search, then you need to go depth wise. Depth wise means starting from 1, you are going to 2, then 4, then 6, then you are going up. Okay. So that is actually main difference between the DFS and BFS. So now I'm going to start with this breadth first search. How to do this thing? Okay, here I need two things. One is visited array, another one is, if you want to implement BFS, I need a queue, and if you want to implement DFS, you need a stack. That is the difference. Okay, otherwise all other things are going to remain same. So here I am taking one visited array, and in that array, the visited of all the nodes is set to 0. Why? Because right now I'm saying I have not visited, I have not traversed any node. So this queue is also empty. Now you can start from any node. It won't be given to you. You can start from any node. Suppose here I'm starting with this 1. Okay. So this 1 you will insert in a queue. Okay. So 1 is coming over here. And once you have inserted that 1 in a queue, the visited of that would be set to 1. Okay. So visited of this would be set to 1. Okay. So that was the first step. Now next step is that you have to delete the element from a queue. So there is a single element. I will delete that and I will write down in the output that the output is 1. Okay. So I'm going to the next slide. This one. Just see here what we did in the previous slide. What I told you, delete this 1 from the queue. Okay, and print it. Okay, just see, 1 is deleted from the queue and the 1 is printed. So this is your actually the output. Okay, now next step. What is the next step? That all the nodes that are connected to 1, you have to take those. So what are the nodes that are connected to 1? Okay, 2 is connected and 3 is connected. So you have to insert them into a queue, into this queue. But before doing that, you need to check that is visited of all those nodes are 0. Okay, Because if the visited of those nodes is 1, then you don't have to insert that in a queue. Why? Because we have already visited them. Okay. Now just check what is the visited of 2, that is still 0. What is visited of 3? Still 0. So you can insert them into a queue. So 2 and 3 would be inserted into a queue. So once they are inserted, visited of them will be set to 1. So 1, 1 is over there. Fine. So what is the next step? Next step is that you have to delete the element from a queue. Now which element would be deleted? This 2, because that is at the front end. Okay. So that was the first element that you inserted. You can insert 3, 2 also. That doesn't matter. It can be 2, 3 or 3, 2. Right now it is 2, 3. So what I will do? I will delete this 2. I'll print it. Okay. I'll delete this 2 and I'm going to print this one. Just see, 2 is deleted and 2 is printed over here. But once you have printed or deleted 2, what you have to do, you need to check what are the nodes connected to 2 now. Now what are the nodes connected to 2? You have 4 and 5. Okay, you need to check there. You have to insert them into a queue, but before insertion you need to check their visited. So in the previous slide you need to check that what was the visited of them, 4 and 5. Visited of 4 and 5 was 0. So I can insert them into a queue. Okay, so what I did, I deleted 2 from this queue, you print it, and then all the nodes connected to 2, that is 4 and 5. What is the visited of 4 and 5? Still 0. So you can insert them into a queue. So 4 and 5 would be inserted into a queue. Okay. So next, again the steps are going to remain same. You have to do this thing until your queue is empty. So what's the next element that you are going to delete from queue? That would be your 3. Delete this 3, print it. Now all the nodes connected to 3. So what are the nodes connected to 3? 1 and 5. But visited of 1 and 5, that is already your 1. So I won't take this one. Okay, means I won't insert 1 and 5 again in the queue. So 3 was deleted, 3 was printed. So next, what you have to delete now? You have to delete now 4. Delete 4, print it. Then all the nodes now connected to 4. Check those. 2, 5 and 6. But the visited of 2 and 5, that is already 1. So I won't take this. You take 6. So 6 would be inserted into a queue and the visited of that would be set to 1. So it should be like this: 4, 5, 6 and 1. Okay. Just see this. 4, 5 and 6. You deleted 3 and all the nodes connected to, okay, it was we had deleted 3, not 4. So all the nodes connected to 3 you need to check. So what are the nodes connected to 3? That is your 5 and 1. But 5 and 1, visited of them is already 1. Okay, so 3 is just now printed. Next you have to delete 4. When you are deleting 4, then you need to check. That is 2, 5, 6. So that was the next step over here. So you are deleting 4, you are printing it, all the nodes connected to 4, that is 2, 5 and 6. 2, 5 and 6. What is the visited of 6 right now? It is 0. So it would be set to 1 and you are inserting 6 into the queue. Now the next element that you have to delete is your 5. Delete 5, print it. Okay, all the nodes connected to 5, check those. Okay, that is 3, 4 and 6. But already visited of all the nodes is set to actually 1. You don't need to check it again. So 5 would be printed. Just see, 5 is printed over here. Next you have to delete 6. Okay, all the nodes connected to 6, 4 and 5 already visited is 1. So 6 would be printed. Okay, now there is no element in the queue. Queue is empty. So this is the output of your BFS. Just check now. 1, that means firstly you visited 1, then 2, 3, that means breadth-wise. 2, then 3, then is 4, 5, that means 4, 5, and then is your 6. Answer can be like this also. If when you will do, you may get the answer like this: 1, then first 3, then 2, then it may be 5, then 4, and then 6. So this is also correct. Okay. So again, I'm repeating all these steps what we have done. Then I will discuss the algorithm. What you have to do, you need to start from a node. That node I will assume is your source node. This is your source node. Okay. So first you have to take one array also. The visitor of all the nodes will be set to 0 in that, and Q is empty right now. So first of all, the source node would be inserted into a queue, and visitor of that would be set to 1. Then next step, you have to delete the element from the queue. Then all the nodes connected to 1, all the nodes connected to 1 are your 2 and 3. You will be inserting that into a queue, and the visitor of them will be set to 1. So visitor of them is set to 1. Now next you have to, and you are printing it. Once you are deleting the element, you are printing it. This is the output. Next you have to delete 2, print it, all the nodes connected to 2, 4 and 5. So you will insert them into a queue. I'm inserting them into a queue, and visitor of them would be set to 1. Next you have to delete 3, from a queue, print it, all the nodes connected to 3, okay, 1 and 5, but 1 and 5 visitor of them is already 1, so I don't need to do anything else. So next delete 4, okay, print it, all the nodes that are connected to 4, that is your 5, 6 and 2. So 2 and 5, that is already 1, 6 is your still 0, so 6 visitor of that will be set to 1, and I'm inserting that into a queue. Next you delete 5, print it, all the nodes connected to 5. The nodes connected to 5 are 4, 6, 3. So already their visited is 1. So next you will delete 6 and print it. Okay. And after that there is no element in the queue. So this is your output. So I did this thing in over here only in one step. Fine. Now I will discuss the algorithm. Before that I will tell you what is the complexity of this. Okay, complexity of this breadth first search is big O of V plus E, where V is the number of vertices and E is the number of edges. V plus E. Like suppose if you are having 5 vertices and suppose 7 edges, so it would be in the order of 5 plus 7. So this is the algorithm. Okay, so whatever I have told you, that thing you can write down in algorithm step by step. So what was the first step? This is BFS. If graph is given to you, and S is what? S is the source node. Like in my example, what was S? S was your 1. So what was the first thing? You are taking a queue. Suppose Q is a queue. You have to insert, first of all, what we had done, we had inserted the source node in a queue. So Q dot NQS. Instead of writing, NQ means inserting in a queue. Suppose you are having a function to insert. Instead of this, you can write down a simple line that insert S in a queue until all the neighbor vertices are marked, or simply insert S in a queue. Okay. Then we will mark S as visited. Okay. Or you can take one array visited and you can say visited of S is 1, or just say mark S as visited. Okay. Next, what I have told you, what you need to do, you need to do all these things while queue is not empty. So while queue is not, queue is what? Your queue, this queue. It is not empty. What you have to do? Remove the element from a queue. So you can say queue dot dequeue. Delete the element, store that in a V. Okay. Next, what you have to do? You need to check what are the different nodes that are connected to V. So for all the neighbors W of V in graph, suppose all the neighbors are W. Okay. All the neighbors you have stored over here. If it is not visited, you have to insert that neighbor into a queue, but only if it is not visited. So if W is not visited, insert that into a queue and mark this as visited. Mark W as visited. Next, again you will go there, delete that element. Okay, here if you want, you can write down one line that print this V. Once you are deleting over here, what you have to do, you have to print it. Okay, so you can write down print v, print v over here. Fine. So next you are taking all the neighbors of this. So whatever I have told you, the same thing you can put it over here. So again, I'm repeating this. What you need to do, firstly, you are taking the source node. Like in our example, we had taken this one as the source node and I had inserted that into a queue. Okay. So, and the visited of that would be set to 1. So I did that. Insert that, visited would be set to 1. Then you will delete from the queue. You have to print it. Then all the neighbors that are connected to V, you need to check if they are not visited, insert that into a queue and mark them as visited. Next, again you need to delete the next element from the queue, print it. All the neighbors that are connected to this, if they are not visited, you have to delete them and mark them as visited. So you are doing this thing until your queue is empty. Once your queue is empty, you are coming out of that. Okay. So this algorithm you can do. This is very important. Next is applications where you can use this BFS. So first application is that we can use the BFS to find out the shortest path in a graph. Okay. Shortest path in a graph means suppose a graph is given to you. Weighted graph is given to you. Suppose the weight of this is 6, 7, 8, 9, 10, 11 and I want to find out what is the shortest path from 1 to 6. It can be this one, it can be this one, it can be this. Okay, so I need to check all these things and you can find out what is the shortest path. So for that you are having this, many algorithms are there, so we can use BFS. Next is that peer-to-peer networks. Like in peer-to-peer network, it can be used to find out all the neighbor nodes. Okay, then in social networking site websites, it can be used to find out people within a distance k from a person. Suppose in that networking website you want to check, like on Facebook you want to check if you are person k, what are the different persons connected to this one. So that can be done in GPS navigation system. And this is important in broadcasting. Like in broadcasting, it can be used to broadcast the packets breadthwise to all the nodes. And next is cycle detection in undirected graph. Okay, here you can use BFS or DFS. Cycle detection means to check whether a graph is having a cycle or not. Okay, so actually this is very important application. It is mainly used in TSP. A cycle is that you are starting from 1, going to all other nodes and coming back to 1. If it is possible, that is a cycle. So it can be used to find out that cycle. Okay. So this is all about the BFS. In my next lecture, I will tell you about the DFS, and DFS is similar to BFS. Only difference is that instead of queue, you have to use a stack.